Hello, everybody. Welcome to my presentation. Today, I'm going to be going over a uh, primarily focused on code and thinking about code. Uh, I'm really hoping that all the computer science students in the audience, I want you to start thinking about why you write code the way that you do. And I don't generally mean that in a philosophical sense. I mean, when you're writing a particular class or a piece of functionality, why are you writing it there? Why put it into that class or that folder? Why is this method doing that? And where would you place this thing? And then with that organization, what do you want to do with it? How do you deal with things where this piece of functionality and that piece of functionality are pretty much the same, right? What is the strengths and weaknesses of whatever organization of code that you've decided on? Um, I'm going to be starting off with a significantly simplified and abridged version of my journey, starting as the very first project that I worked on, or one of the very first projects I worked on at Invoke, to today. Uh, some slight edits to make things a little bit cleaner, but uh, just speak aloud if you have questions in chat, or put them in chat if you have them, and we can answer them towards the end. Um, just whatever, if you write it down, you can ask that at the end, or you can ask in the middle. No problem either way. For those of you who are experienced developers, please, as we go through here, when you have insight, feedback, and experience or stories to share, those will be valuable contributions to this discussion. I'd like to make sure that knowledge can get passed on to those who are newer to the software development experience, and perhaps allow them to start past some of the initial hurdles that we experienced where we started. And so to kick things off, we will excitedly begin with ASPX. I know that several of you have likely begun to groan on the inside with that. I know at least one in the audience who likely did. So ASPX is old. Web Forms is another, is ASP.NET Web Forms is technically what it is called. And it's one of the first projects or technologies I had to use as a developer. And so this project in question started pre-2008, and I got placed on it as the intern, working on the project that nobody else really wanted to work on. And so the project was technically complete, but it had a lot of things that needed to change and constantly be altered. So super quick introduction. You probably have seen .aspx extension on websites somewhere. This is what the code for that might look like. This renders a very simple web page. And on here, it's just HTML with a little bit of special tags for certain actions. And so on here, all the application's logic is what's going to be living in what's called the code behind. So on here, if you see this button right here, if you click on this button, it calls this method, and that's just a function of web forms. And so all of the application logic, in the case of the actual program that I worked on, all hundreds of pages of that application, almost all of the logic related to its function lived in code behind, or maybe it's like, say, a stored procedure or something, but that's aside the point. Pretty much all of the code that existed, for example, you can see here a simple check, right? Make sure that the name is filled in when they're trying to save a user, right? All of you done precondition checks like this. So pretty much automatically, I'm sure most of you have thought about how this gets painful very quickly, right? With this code behind being the place where all of your things, all the actions that you're trying to solve for your client live. If it's all on this code behind, your code is thrown about everywhere that there's user interaction, and it's not isolated to any particular spot. So you could have logic that's checking, for example, a user's email in multiple spots throughout this application. You could easily end up duplicating things. So the easiest case to show is, for example, validation. So we have, for example, we want to make sure that we never have a user without a name and that we never have a user that doesn't have a valid email address, as an example. And so from here, you can see that if we had hundreds of pages, then that gets scattered about. Further, with all of the code being in the code behind, there are certain pages that just do too much. We have pages that, for example, would have like grids of data, and you'd have to check all these checkboxes and enter all these sorts of numbers, and you'd end up with thousands of lines of code in a single file. And as you might imagine, that's pretty much unmaintainable if you have more than one person trying to edit that same file at the same time. For those of you who worked in any project class whatsoever, you've encountered the merge conflict. Just imagine that you have a file that's 1,000 lines long and both of you did different things to it. Be pretty hard to deal with. So we need to mitigate that somehow, some way, right? Simplest thing, let's try and get rid of some duplication of at least we'll pick on validation logic, right? And so we need to think about this a little bit, programmers' problems. It's not just problems for our client, but problems that programming has caused programmers. And so let's reduce the amount of duplication. And so this is where I would normally say go into solid principles as a deeper dive. Instead, I'd like anyone who has not heard of solid principles to write the term solid principles down and look it up at your leisure. The main takeaway right now is right now our pages as a whole are doing too much, and so we want to reduce how much an individual page does by pulling out, in this case, validation and isolating it so there's one thing responsible for validation. There's a single responsibility, aka the S in solid principles. And so in this web form, right, we can introduce just a very simple helper, a validator class that is responsible for doing the validation logic. So this validator performs the same sort of check here, but in a way that is isolated outside of the page itself. What does this validator look like? It is using something called Fluent Validation. I'm going to skim over that for the moment, but the basic idea here is that we have our validation logic isolated to its own class that's responsible for one thing, validating users. So you might imagine a bigger project would have lots of different things that might need validation. You can now have a class per type that you need to validate, and all the rules and even things like the messages that get returned by particular rules being validated, you can make them consistent and not all over the place. So something as simple as misspelling a individual word on one of the error messages makes your project look worse, right? With something like a consistent Fluent validation library as an example, or any sort of centralized validation set of rules, you can instead avoid that sort of problem entirely. And so, in this case, we could, as an example, if we had multiple pages that needed to validate a user object, we could, in fact, get this validator and use it on multiple pages. And so there's only one instance of this, but it can be reused in multiple parts of the application. You can imagine that on a bigger project in the real world, that project was completed or close to complete in 2008, 2009. I got on the project in 2010, so it was already done. All the original developers involved with it are moved off, did other things, and some of them moved jobs, right? And so I'm left like, hey, intern Matt, go ahead and just support this website. It's gonna be fine. And so, you have to figure out where everything is. And so without something, even as just as simple as just having consistent validation rules, you have to go between all sorts of pages to even find, for example, what the validation rules for something might be. When you're working on a team, being able to understand where things are, right, where some piece of functionality should live, if I can discover it without going and asking somebody, that's really what we'd want to aim for. And so in this case, right, I will step real quick back to the validator itself. Fluent Validation, very useful tool. I recommend, especially anyone in 3D3 right now, to go look up this library and read its documentation, as well as figure out what you'd want to do, how to use it properly, right? You can use it improperly and it can make your life more difficult. Just like all tools, This adds a little bit of complexity, but the benefit of that complexity is a net positive for your working project, right? At least as long as everybody on your team is on the same page about what the organization for this is and where it goes and what it should do, right? Now, luckily, I don't have to work on ASPX web forms sites very often. And so my very next project was actually a brand new MVC3 website, circa 2011. Today, I'm actually going to be using ASP.NET Core. I didn't feel that actually making an MVC3 website would actually benefit anyone. To be perfectly honest, I was astounded that I was able to make a brand new web forms project in 2021, just over 10 years since I worked on a completed project from 2008. So first thing with this brand new project was we're going to have a brand new architecture. We're not going to put all this code and this code behind. And the senior software developer over me at the time said, we figured out we're going to do this structure, and we're going to use what's referred to in-tier architecture. I'm going to refer to it as a services architecture, but it's a 3-tier in particular for anybody who cares. And so services will be our first foray into trying to resolve a lot of this code behind problem where we have so much stuff sitting right there scattered throughout the application. And so, as an example, here's a user service. This user service right here, this insert method, does the same thing as our original onClick here. The difference being that the code for, say, creating a brand new user lives within this dedicated user service class. And so this is a silo of business logic. This is the middle tier in a 3-tier system. The first tier is going to be, for example, your code behind here, or in the case of a actual MVC project, it will be something like this, where your controller action would call the service. And so with that, right, we've sort of isolated a little bit of our business logic into this services class. And so the main takeaway here is that we have our business logic independent of, for example, mostly independent of the code behind or the action in MVC, etc. That makes it so we can, say, test this class. We can write unit tests or integration tests against it. Further, whenever we're dealing with this, we can reuse this service and wholesale do particular actions. You might imagine that user service is a little bit contrived, but you could have more complex services that do more work that you don't need to duplicate or copy and paste code around. We don't want to repeat ourselves as developers. That's prone to error, especially if requirements change. And so the concept of inserting a user changes over time, which oftentimes requirements do change in projects. You want your code that's responsible for that, like, business thought of adding a user to be in one spot, if at all possible. You want to make sure that if a change occurs for your requirements, or you misunderstood a requirement and you need to refactor, you have one spot to change it. And so in general, this structure helps, right? You can see how this keeps our business logic, at least as best we can, kind of isolated into this service layer, this middle tier in our 3 tiers. And so extra bonus, pretty big important thing at the time, we were able to better deal with dependency inversion using this. And so dependency inversion is the D in Solid. And what that means is we should not rely on particular instances of methods, right? So we should not rely in, as an example, our controller on the explicit user service, but instead rely on the abstraction of user service. So in this case, we're using an interface to define what our user service, the business logic related to user, looks like, and then implementing it. And further, here's our same fluent validation logic, just we're injecting now a interface, so it's an abstraction, as well as the data access layer, our last tier that actually reaches into the database and does some sort of action. And so this means that we can much more easily test our business logic, whereas before, right, if we had just this helper and code behind, we could test, for example, this user validator, but we can't easily test this code behind method. There's not a good way, right? Or vice versa. If you have a controller action that does a bunch of stuff, there's actually a fair amount of work even today, and it's a lot easier than it was back in the day. But there's if you just want to test user, like inserting a user, you don't necessarily want to have to mock out the entire web system, right? By pulling it out and putting it here, we have a single point that we can choose what we want to test. How integrated do we want our integration tests to be? This also allows us to actually unit test our business logic. And so from here, there's some benefits. The main thing, though, is these services acted as sort of mental glue for me as a relatively new person on the team with less than a year of development experience under my belt at that point, to write code that other more experienced developers can review, quickly comment on, and integrate with in a large code base with multiple people working on it simultaneously. We don't need the mental friction of arguing about our particular piece if whatever we're talking about from a business requirement standpoint fits within our 3-tier architecture, right? So our services here give us a easy avenue to make sure that all of our developers on our team have the same sort of thought process. Now, to actually use it, right, as mentioned, we're injecting it into, say, our MVC controller. How does it get there? Dependency injection. Dependency injection is a very important concept in general. Luckily, these days, we have that integrated quite well with Microsoft's framework. And so ASP.NET Core has made, I think since very first version of ASP.NET Core, they've had this dependency injection system with the services collection that allows us to register types, right? So this is adding items to that registry of types and saying, here, if anybody asks for a data context, use it. If anybody asks for an iValidator of user, use this instance. Here's where that inversion of control pops in, right? We're saying that we need to add a iValidator of user. This user validator is the concrete implementation to use if somebody asks for the interface representing the concept of validating a particular user. Same with our data access layer. We can say this user repository, this is the concrete implementation that we should use, right? And here's user service. There's really only one true implementation here, but for sake of keeping things, again, on interfaces so we can fake it out if we need, we'll use the interface version. And so by doing that here, by registering services, we can use our service inside of the actual controller's actions. And so all we have to do is put it in the constructor, and it is constructor injected. I want to make it clear, though, that dependency injection, right, which is, for example, what this is offered by Microsoft, as well as there's numerous other dependency injection frameworks. I will talk about that at the very end. Those are not inversion of control. Dependency injection is simply a system where some framework is responsible for injecting your dependencies into an object. If your objects are properly structured, then dependency injection, or DI, makes inversion of control possible, or at least more reasonable, because then you don't have to manually create it. If we wanted to manually create a user service, we would have to do something like this. And so you can see here that we make a user service. We then have to make a user repository that has access to, say, a data context. And then we have to punch in the actual user validator. So this and this are fundamentally doing the same thing, but the difference is this is not using dependency injection, though since we are using the interface version, at least in theory, we're kind of doing inversion of control, though technically we're not, because this controller itself knows which instance that we're using. But point being, dependency injection is a critical piece of a puzzle for making maintainable code, because making sure that whenever you're writing code, you're thinking about things at a higher level. Try and avoid needing to think about a lot of things whenever you're doing something simple. I'm inserting a user, so I need a user service, and I'm going to call the insert method. Make sense? So clearly, this is perfect. There's no problems whatsoever, and we're done, right? No. So as you might imagine, lessons were learned and continue to be learned. So code behind, not a great idea. Services, turns out there's some problems. The astute among you probably have realized that there might be some issues. Should, as an example, our user service be responsible for sending an email to a user? Or perhaps if we wanted to add a user to a role, do you think that should go under user service, role service, or perhaps the user role service if we're feeling fancy? You can see how, as an example, we might end up with services that have a method on them, like say insert, that don't meet the expectation of different developers approaching this problem or this domain at the same time, or different times, more importantly. So I today might think that, okay, yeah, adding a user to a role, that goes in the user service. In 2 years, the next person who's going to be touching this code, they might be looking for the add user to a role underneath the authorization service, potentially, right? Because giving somebody authorization as a role, that there's a fair argument there. It's not necessarily one way or the other. You see the ambiguity is it's not just about what will work. All of those options I described will work. But whenever you're talking about working with a team and you're dealing with all the problems that come up with working as a team, you don't want to have arguments like that result in something arbitrary that 2 years down the road, you're like, man, why did I put that there? That's annoying. Right? And then you have to end up refactoring things for not really a good reason, right? You just didn't realize what kind of problems that you're going to have. With these services, as you might imagine, we have a nice short service here. Imagine if we had 50 different actions that could be taken against a user, which honestly isn't that far of a stretch. We certainly, in my experience, had services that could have hundreds, if not breaking 1,000 lines of code inside of them. That is not good. Just like the code behind example, where we had a giant action code behind and there's like thousands of lines, it's doing too much. There's a service that's responsible for so much that any change to it must be made in isolation. I can't have 2 developers working on something that touches that same service class, right? If user service is 1,000 lines long and I have 2 tasks that are both related to the user service, directly or indirectly, I could end up with nasty conflicts. Merge demons would come out of the ground with that kind of change. And so the main thing we want to do is, okay, let's just split the user service, right? Let's pull out some methods and then separate them, and like we'll have a user permissions service and a user admin-y service or something. And then you realize, what do you call those things? How do you group those methods? How do you discover what those methods were after you write the code, 2 years after you write the code, right? Because projects in the real world last a long time. A lot of people can touch them. And you want to avoid really making arbitrary decisions, because what happens is every time somebody new comes to the project, there's a lot of overhead for both your team and the client to actually be able to start making changes at all with any sort of confidence. Even if it's tested, at least that will protect you against a lot of bugs, right? But my experience, a lot of the projects that have been thrown at me from other development places just don't have tests, right? So please write tests. That's a lesson. But in general, with something like this, you don't get, if you make arbitrary decisions later down the road, somebody's going to arbitrarily disagree with you. And so the last problem, aside from discoverability of particular methods, right? Because, for example, if I say I want to find where insert user is, there could be multiple methods called insert on different services. We could end up with problems with cross-cutting concerns. Cross-cutting concerns, for those of you who are unaware, are related to, most simply to describe, things like auditing or logging stuff. So a very basic example might be if I want to audit, for example, every time somebody does stuff on the user service, because users are a pretty sensitive piece of information, we might have something like that allows us to audit code. And so with this, we'll say introduce that as a dependency, and we'll come in here, and then we'll say audit, and we'll say in here, it's like, well, this is insert user, and it was not successful. And down here, we'll say something like it was, that was successful. And then over here, we're going to say like, yeah, we're going to get all the users. Get all the users. And so, as you can imagine, if we wanted to do this for every method on every service on a big project, you're looking at hundreds of calls like this or more, because you can see even this single method insert, which is very simple, ends up with 2 branches of execution, which might alter what we're actually auditing. So you have to go through every service, every method, scan every method to understand then what the flow control here is doing, and then add your necessary audit statements. I don't know about you, that sounds terrible. And so that's basically a non-starter, right? For a big project, that's just a huge undertaking. And so how do we deal with this cross-cutting concern of audit? And it's not just audit, but I'm going to pick on that one for now. Another way of looking about this, right, is instead of directly putting all of these, say, audit things and sprinkling it out throughout here, we can take a concept that's a little bit outside of actually C# called aspect-oriented programming. And aspect-oriented programming, or AOP, is we want to have our changes to our behavior, right? For example, insert, we want to change to the behavior of this method without actually altering the body of this method at all. We don't want to have to write code right here next to this in order to do it. Now, any guesses as to what that might be? I'll go ahead and cheat, and we're going to say decoration, because decorators, or the decorator pattern, is easy to understand, easy to write. And so here, we'll say that, again, because we programmed our user service against a abstraction, we can instead wrap, say, our call to something like insert on our user service with an audit service that makes sure that whenever we do this action, we always say audit something, regardless of what flow control mechanisms are here, aside from exceptions, but I'm not going to worry about that for now. That does not get changed, right? So we can just think of the concept of inserting a user and then just audit. So this vastly simplifies how much code we have to go through. Instead of having to look into the details of, say, insert, we just need to look at the signature, right? The concept of insert, and write our audit code here. Now, this is nice. It's at least something. And using it is pretty easy. If we were to imagine this being manually created over here, all we have to do is this, and now we're technically audited, right? Notice down here, this code didn't change at all. It's still hitting an ICE service, but now it's an audited user service, right? So main problem here is we are way duplicating these method names, as well as we have to, every single method for every single service interface, we have to implement a decorator class like this in order to do this. So it's a step up, because at least then we don't have to pollute, say, every method within user service here with the details of audit. But for each cross-cutting concern that, say, this aspect represents, we have to make an additional decorator and implement every method here, which ends up being every single method that is in our business domain, at least for something like audit, at least probably, right? You might get away with some cases where you don't do anything, but the interface, if nothing else, needs to have this signature on it. So surely we can do better. And so this is around, say, 2014, and for those in Botians and the here today, I did in fact go look back at the original repositories, and that is when we wrote our initial mediator. Mediators are different. Mediators are going to serve a very similar purpose as our services here. But mediators instead are going to isolate each action even further. So before we had this service that had the insert method, and instead now we have a class representing, in this case, the request to create a user, and we have something that's handling that request as a separate class. So that means for every method that existed in one of our services in our 3-tier structure, we now have at least 2 classes representing that method. One class representing the actual method's signature, if you will, what it takes in as an argument existing as parameters to that class, and the body here for actually performing the action existing within this handler itself. And so this concept is, you can think of it a little bit like a request gets sent out. Something is going to see this request and know where to put that request so that this handle method gets called appropriately. That thing that routes this request to the appropriate handler is a mediator. And so mediator is a pattern. So the mediator pattern is its own construct. There is a project called Mediator by Jimmy Bogart that I'm using. I wish that I could go back in time and hand myself the Mediator project before we had to make our own mediator in 2014, because as it turns out, we actually started coding we started coding our own mediator at the same time Jimmy Bogart was making his mediator, and it's double the work. So, well, lesson learned, just wait another year and then start using somebody else's. But we don't have services anymore, right? There's no, in this new architecture, the mediator exists and we have commands or queries, and I'll talk about CQS in a little bit, but basically we have a thing that does an action and then the thing responsible for actually executing that action, and then we have the mediator. So there's 3 pieces there. Mediator is the tunnel, the request goes into the tunnel, the result inside the tunnel gets generated by this handle method, and then the answer is spit back out. And so we can hop on over to what this looks like in a controller. Again, this is the same function as before. We're still just creating a user, but now we're taking in, say, a mediator instead of a service, right? Because again, when we were originally doing this in our services structure, we injected a service for the user and then called this method. And instead, we're injecting a mediator and asking this mediator to basically handle this request that's coming in. And so this structure has some disadvantages. Clearly, we're going to have a lot of classes, right? Every single method that existed on every single one of our services will now be at a minimum 2 separate classes, right? And so that's a lot of classes. And you might very reasonably wonder, why would you do that? And the answer is that this structure, while having more classes, then allows us to really reduce the responsibility of each of those classes. We have significantly reduced how much a particular, say, request or command or query does, what it's responsible for, to pretty much the minimal amount that we can have for a particular business piece of logic. And now we can basically just rely on these on our mediator as a method of getting results out of a bunch of these commands and these handlers. And so from here, we're working on teams, right? If I'm making something and it's going to go in a particular command, even if we're both working on something related to user, as long as our business, the thing that we're trying to work on, is 2 separate pieces of business logic that might be related to user, our commands are not going to interfere with each other, right? If somebody's doing a change password request workflow and I'm doing a thing to add users to roles, then our commands will never like need to be the same file, right? We'll have separate files here. Now, by having these smaller classes, we reduce the amount of merge conflicts. And it also gives us another really big benefit, but I want to talk about complexity. This is more complex than our services, but that complexity is worth it in the end, right? So that's the main judge, and I want you to think about it whenever you're talking about architecture, codes, organization, and working with a team. It's not just what's good, right, and what works. It's what is the simplest thing that will allow us all to work in a consistent manner against a code base to make a deliverable in an efficient manner. So, great thing. How do we deal with the whole aspect-oriented programming, cross-cutting concerns with this? That's even better. Remember the audit that we had before, right? So if we go over here and we look at our, say, audited user service, this, we had to make a decorator for every single instance of a service. Instead, now our audit can have one aspect, right? And so now we can actually, all of our, every command, every query, every request that's going through this will be audited. And it is just this code. We don't need to make anything else. Now, this is grossly simple, and you probably want something a little bit better, but you can see how this means that I just wrote basically all of the audit for everything. And I didn't need to go implement. And the reason for that is because all of our commands, all of our handlers, they are all implementing the same interface. They all have the same signature here with handle. And because there's a single signature like this, we're capable of using, and this is a pipeline feature of Mediator, which is again just an implementation of Mediator by Jimmy Bogart. This chain of responsibility, that's what this pipeline is. It's a chain of responsibility. Chain of responsibility is a pattern. I want to keep going before I go too far down that rabbit hole, where basically this is only responsible for audit. Further, we can do things like this, where we can even pull out our validation so that our validation is done in a consistent manner. So if you recall, in our original, we had to take in the validator inside of our handler, do it, and then conditionally do something else. We can actually write aspects and behavior that now we can kind of freely change how we think about cross-cutting concerns. We can isolate even the calls to validation in a way that allows us to stop thinking about the nuts and bolts of it and make actual business requirements get satisfied here, right? Even better, it's testable and it's reusable, right? There's caveats to this, and people will argue with you about it, but you can call handlers from other handlers. So you can come in here and say, I request handler of something, right? Let's say, I'm going to call the same one, but so this right here, you can go execute other commands inside commands and get the results out, right? So it allows you to compose things really well and to be able to share business logic between disparate parts of the system. That's amazingly useful whenever you're talking about bigger, more complex domains, when we're not just inserting records. And so how do we actually achieve something like this? That gets into some nitty-gritty that I don't have time for, so I'm going to have to skip that part. You can do things, another example would be caching, right? So if we had, for example, we had the get all before on our services, we had the get all users. This is the, again, the Mediator version of that. This is a query, it gets data rather than modifies data. And the cache query can actually exist simply as the same exact code we had in the normal one, but we can use, again, our mediator as a method to define in a common way, in a way that's independent of what the actual method, let's say get users, is, and fetch that data in a way that is agnostic to the actual implementation of getting all users, right? This does not tell us what type of request. This is all requests, right? Any request that defines itself as being cached goes through here, right? And so the main thing here is with all of these, just like before, whenever we're talking about mediation, our mediator, our consumer, our user controller doesn't know any of those details. It just gets some results out from sending a request down to the correct command or query. And so, just like before, we're using dependency injection to actually define all of our different commands or different queries, as well as say all of our different aspects, right? So for example, if we wanted to have auditing and different caching, auditing, validation, you can do things here just by registering it in your dependency injection framework. And so very low on time now, but on here, the main thing I want you to take away with this is that whenever we're talking about code structure, right? If we're talking about these various ways of organizing code, we started out really simple with our, say, simple ASPX with code behind. And we increased and incrementally added complexity to how we architected our solutions, right? Going from this to our services, and then finally going all the way up to mediators, with the goal of solving problems not related to the individual client we're working for, but the problems related to a programmer making programs on a team, right? Those are the classifications, and we'll call it a meta problem, where you're writing code and that code is getting in the way of writing more code because of all the various reasons we've discussed. Big classes. We have too many things going on in a single method. We can't deal with cross-cutting concerns, right? And so whenever we're talking about things, we want to avoid adding complexity for the sake of complexity, but we want to make sure that we're open to how can we adjust our architecture to have a net positive in complexity, right? Even though there's a lot more classes, each class can be a little bit more succinct. It's a little bit more boilerplate, but I mean, there's ways around that problem, right? You can have like code snippets as an example to get around some of the boilerplate, rituals involved with declaring a command and declaring a handler. But you can do that incrementally, and you can try and evaluate what's actually useful to you and your team. And so, in brief, just think critically about not just the code that you're writing in terms of how to solve this particular business, but how do you architect your code to make sure that as you're writing code, it doesn't turn into a ball of yarn that you can't see through and you don't know what it is that it's truly doing. So brief technologies I'd like to tack on here at the end that I've kind of skipped over. AutoMapper, super useful tool for any of you in C# land. Use it extensively, and it is very helpful to, again, just like we isolated our validators into classes dedicated for the purposes of creating validation rules against arbitrary objects, we can create profiles that define the mapping of one object type to another in a consistent way, where a class represents the mapping rules for whatever it is. That's a huge benefit. It isolates that. We reduce the size of our classes, and then again, with more classes that are smaller and single responsibility, again, we end up with code that has fewer merge conflicts, that has fewer problems where two people are trying to change the same thing without realizing it. Next up, automatic registration of dependencies in any sort of dependency and injection framework is super important because you will mess up making this by hand, right? I skipped over it, but there is a difference between scoped and transient dependencies. And so if you mess that up, especially if you mess up in the Microsoft offered one, it won't tell you. It'll just blow up in weird ways or just will not work in the way that you expect, and you might not even spot it until production. So be careful with that whenever you're dealing with any sort of service registration here. It is significant and important, right? Again, this is complex. The complexity was worth it in the end. And so last note here was you want to say, for example, simple injector is a different dependency injection framework that I highly recommend you look into. Simple injector, the main thing I like about it is it has some really good automatic registration, and even better, it has a huge diagnostic suite that will tell you when you've messed up, and it will tell you why you messed up, and basically use it because it will tell you when you do it wrong, and it'll do it very early. It'll do it whenever your program first starts up, and that's invaluable when you're starting to just dip your toes into these sorts of structures. I think we got 15 minutes left, roughly. And so I'd like to make sure that I leave time open for questions. So does anybody have questions or comments? If not, I have extraneous topics that I will add as an addendum. Also, thank you, Travis, for linking in chat Mediator. I will link AutoMapper and Simple Injector while we're at it. Go for it. No. Not once have I looked back and said, man, I wish I could put code in the code behind. Yep. So just for sake of the recording, history lesson of here is that in the olden days of, say, Visual Basic, this code, right, where we had on click and then there was some event handler that listening to that event was the paradigm that everybody made desktop applications for. Everything was on your computer. It wasn't in the browser, wasn't in JavaScript, there wasn't a server. It was just a desktop application. The reason why it's called web forms is because there's something called WinForms that existed before it, and the WinForms is a desktop application that was circa Windows 98, right? And so it's the web form was a stepping block that Microsoft made to help people who are used to desktop programming step into web development, basically. And also, there's a comment that I don't know what most of this is. Some of the details. There's not enough time to go over to truly say grasp all of it. The main thing I want you to take away with, if nothing else, is think critically about how you're organizing your code and seek lessons from, say, talks like this, articles on the internet, because people will argue, people will disagree with me wholeheartedly on certain topics here. You need to consume like their thought process and make a decision that fits your teams. Because whether it's at work or as a project class or what have you, it's not just about making code. It's about making code in such a way that your team can efficiently make more code. Okay, side tangents. topic I didn't touch on, but I'd like to talk about now, since it sounds like we're out of questions for the moment, is the concept of unit of work and transactional safety. And so transactional safety is another cross-cutting concern. That is, if we were to be inserting for example, a user and also adding a role to that user, depending on how you do it, you could end up with a case where the user is added to your database, but the role related to that user is not being added. So transactional safety helps that. You can do transactional safety using, in C# land, you can use the system.transactions namespace. Not terribly important. So just if you Google search C# transaction scope, you'll get it, and I recommend you read the documentation. But this is like the simplest thing. And a transaction is just anytime you enter a mediator call, in the case of this mediation, the transaction starts when you call this method and ends after you get back the result, is our general rule of thumb. And the reason for that is, if you have a single mediation, you want all of the changes representing that call to either completely work or completely be rejected, right? Unit of work is a separate thing from transactional safety. Unit of work is what Entity Framework gives you whenever you're talking about multiple changes. Whenever you call save changes on a data context in Entity Framework, you're saying, I'm done with this unit of work, start me a new one. A transaction is above that. A transaction can exist between multiple calls to end the current unit of work. You can give that behavior, right? And I have this commented out here because it yells at you otherwise. And nope. Here. And so, like every other behavior, again, behaviors representing an aspect of a cross-cutting concern, and its actual implementation being a chain of responsibility within your mediator, represents starting a transaction whenever the process begins, right? So this is before your processing starts. You're going to call transaction start. And then after you're all done, the last thing that's going to happen is you're going to complete your transaction. Now, just caveats here. Probably we're using exceptions as an example to say it failed, throw an exception. You had validation violation, throw an exception. Not ideal. I'll leave it to a exercise for the reader to figure out how you might change that so you're no longer just dealing with exceptions being thrown everywhere. I'd like to talk a little bit more about aspect-oriented programming then, assuming there are no other questions. There are a couple of useful tools out there dealing with aspect-oriented programming. One of them is PostSharp. This is expensive, it's fancy, and it's hard to use properly. It's super, super powerful. Just be aware that we didn't use it because it was too complex for what we ended up needing it for. And it costs a lot of money too. But Fody is another one. And to make sure you do C# apparently. Both of these things, PostSharp and Fody, implement aspects in aspect-oriented programming using IL weaving. And it's witch magic is my summary for that. My personal preference is keeping it as simple as you can, adding no more complexity than what is needed in order to achieve your overall goal. Okay. So I think that's pretty much it. So any other questions? So sorry if that went too quickly, but it was much abbreviated and covered literally 10 years of architectural discussion and concisely as I possibly could.